question, we've already been given the f of x function, which is sine 3x, which is this function with a lighter color. And I took the liberty to draw the g of x function. The g of x function is a transformation of the cos function. If we were to draw the cos function, it would trail somewhere along here. The dotted orange curve would be our normal cos function, but it is given that this g of x is cos x minus 30, which means that it's been moved 30 degrees to the right. That is why this x-intercept moves from 90 to 120, 30 degrees. From negative 90 to negative 60, just move it 30 degrees. Even the turning point, we move from this one where x is 0 to positive 30. This blue curve represents the transformation of the normal cos function, cos x minus 30. We move the cos function 30 degrees to the right. The next question is asking us for the period of the fx function. The period is the number of degrees that it takes for a function to complete a full cycle. With the f of x makes a complete cycle from 0 to 120. Therefore, the period for of f of x is equal to 120 degrees. It takes it 120 degrees to complete a full cycle. The next question is asking us which values of x is our function of f greater than 0. When we talk about these type of questions, whether it's in trig or in the functions, whenever we say values of x for which the fx is greater than 0, we want the values of x for which the y is greater than 0. So when we look at the f of x function, the only region where the y is greater than 0, meaning that it's positive, is this region. This region. So this region, our y is positive. We're looking for these x values for which the y is positive, from 0 to 60. Therefore, where x is less than 60 but greater than 0, these are where we find the function being greater than 0 The last question is asking us for values of x for which the gx is decreasing but f of x is increasing. The same thing applies here. We're looking for the values of x for which the y values of the gx function, of the blue function, are decreasing. So when we look at the gx function from this point to that point, the y values are increasing. But from this point to this point, the y values are decreasing. This is a point that we're interested in for the gx function. And then when also looking for the values of x for which f of x is increasing, the values of x for which the y values are increasing for the f of x function. The only regions where the f of x is increasing are from this point to that point. But this is not what we're looking for because the g of x is not decreasing on this side. But when we look at this side, we already know that for our g of x, values from this point to this point are decreasing. They are decreasing. And then for the f of x, values from this point all the way to that point are increasing. So the regions that we're interested in are where the g of x is decreasing, but the f of x is increasing. So this region, this is where we're interested. Where the g of x is decreasing, but f of x is increasing. It is between 90 and 120. Therefore, x values less than 120 degrees, greater than 90 degrees. This is where you find the g of x decreasing, but the f of x